Hello everyone, my name is Sophia, and in this little video series, I'm going to be talking about data visualization in R. Now in this first video, I'm really going to be focusing on the process as a whole. So I'm not going to be going too in depth into any particular type of graph, any particular functions, but I'm going to be, starting from the very beginning, downloading some data, sorting through that data and making it into a cool looking visualization. So first, before I start looking for that data, I wanted to talk about something called packages in R. And the reason I'm talking about this is for this series, I'm not going to be using just the base R that you get if you go onto their website and install R. I'm going to be using something called R packages. And these are extremely common for anyone who visualizes data because many of them contain functions that the base R doesn't have. And they often make data just look nicer when you visualize it. It's most easier to use. So without further ado, I'm going to be first looking at this little, it's not little actually, this is a huge list of all of the packages in R that you can install. These are all free. They're really easy to install. You don't even need to go here and look for them. I'll show this later, but you just go into R itself and you can install any of these. And here it's this sort of repository is called CRAN, stands for Comprehensive R Archive Network. And as you can see, no one needs all of these, which is why they don't all come with base R when you install R, because that would be an enormous amount of storage that would be taken up. But anyone who wants to work with data can go in here, pick and choose the ones they need, install those, and then work with those, which is what we're going to be doing. But I just wanted to show you just how many there are. As you can see, I'm scrolling down, I'm still in the A's. There is a huge, huge number of packages available. And going back here, here is a list sort of the packages I'm going to be using in this series. I might not even use all of these, but these are the ones that might come in handy as I'm sort of working through the basics of data visualization. And I'm not going to run this code right now because I've already installed these packages, but I will link this code and any other code that I write throughout this video in the description of this video. So go check that out if you're following along. But as you can see, if you wanted to install all this, you would store all of these different packages into a variable, and then install.packages that variable, and you would see a bunch of red text pop up, and eventually it would install all of them. And all right, that was kind of boring, but also necessary since I'm going to be working with some of these packages in my visualizations. But now on to the interesting part, which is working with data. And throughout these videos, I'm going to be mainly using data found in this Tidy Tuesday database. Now, Tidy Tuesday is kind of a series of data that is released every Tuesday, as you can probably tell from the title, by, I believe, the R developers or someone associated with R. And this data is all available on GitHub. You can go in from any year starting in 2018. Here we can go to 2021. You can see all of this has already been released. And every week, people who are interested in data visualization, they go in, they work with this data, everyone from beginners to people who are really advanced, and they come up with their own visualizations. So here I've just gone on Twitter and searched up sort of Tidy Tuesday visualizations, and you can see people do all sorts of stuff. The latest one, as of me filming this, the latest data that they came out with was, I think, was something to do with salaries. So here you see someone came up with a visualization. Here's a completely different visualization using the same data. Again, something very different. And yeah, this is just a really cool way for people to practice their visualization skills, which is why I'm going to be using some of that Tidy Tuesday data in this video and in other videos to come. Now, the one I'm going to be focusing on in this video, the data set I'm going to be focusing on, is from bechdelltest.com, which, as you can probably guess, has to do with the Bechdel test. And this data was released a couple weeks ago, actually not a couple weeks ago, in March. This data was released in March, but I thought it was interesting, so I just picked it up, and that's the one we're going to be working with in this video. Now, before I start downloading this data, taking this data apart, I just want to explain what it's all about. And it's nice, here in GitHub, they provide us with a little description here. So basically, this data probably won't make a lot of practical sense if you don't know what the Bechdel test is. So I'm going to explain it really quickly. Basically, the Bechdel test was invented by Alison Bechdel as a way of measuring the female representation in movies, and not just female representation, but meaningful female representation that wasn't built on other male characters in the movie. And the Bechdel test gives a score of 0 to 3 for any particular movie. You can earn a total of 3 points by meeting 3 different criteria. The first criteria is that there are at least 2 named female characters in a movie. The second criteria is that these 2 named female characters talk to each other at least once in the movie. And the third criteria is that these 2 named female characters talk about something other than a man in the course of the movie. And this seems pretty simple, but you would be surprised by how many movies don't fit this standard. And that's kind of what we're going to be looking at in this when we're analyzing this data. So Tidy Tuesday actually packages this data really well for us. It's really easy to access. Right up here, it tells us how to get the data. And actually, the first thing we want to do, if you don't have it yet, is to install this package, Tidy Tuesday R. Again, that's one of those packages in the archive, which will let us access the data easily. So I think I already installed this, but I'm just going to go ahead, copy and paste that into here and make sure I'm installing that. Run it. So I'm just going to run this line of code. I'm actually not going to run this line of code because I already installed the package and R is giving me some problems when I try to install it again. So if you don't have this Tidy Tuesday package, please install it. And after that, we're going to do the fun part, which is loading this data into R. And again, I'm just going to copy this code right here that is given to us and run it. Boom. And now we have our data that we're going to be working with from March, the Tidy Tuesday series. And now, we see there's some data here. It looks like very large data. We have almost 9,000 rows, 5 columns. So it's helpful that this database already gives us kind of a rundown of what's happening in this data. So let's take a look at that. So this is the data set that I'm really going to be focusing on, the raw Bechdel data set, although there's also this one which goes a lot more in depth, budgets of the films, their gross income, all sorts of things, their IMDb rating. And this video, I don't want to worry about this mess of variables, so I'm just going to stick with this this simpler. I don't know if it's simpler, but it's more condensed data. Yeah, so let's take a look at the variables that we have. We have the year that this film was released, its ID, its IMDb ID. You can probably already tell we're not going to be too worried about those. Its title and its rating from 0 to 3. Here are the criteria again. And yeah, let's get to the fun stuff. Now, the first thing we're gonna do whenever we get any large unsorted piece of data is to organize it in a way that's going to be helpful for us. And this is often called cleaning your data or processing your data. And I'm going to be doing this with the help of another package called the dplyr package. And that was one of the ones that I indicated in that list. And now to really access that package, from the library, we're just going to hit this command, library, the name of the package, and we're going to run that, and we should be good to go now. And the reason I did that is some of the commands I'm going to be using are part of this package, and they make it easier to kind of sort through data than just using the commands of base R. And again, this is one of the ones that are widely used by statisticians, by anyone who's analyzing data. And now as we begin to sort our data, the question comes up, how do we want to organize it? What do we really want to take from this data? And before we know that, we need to know what we're trying to achieve with this visualization. And you can do all sorts of things with this data. But for this video, I've chosen a particular question that popped into my mind as I was looking at this data, which was, how have these ratings changed over time? And we have two convenient variables for that. We're given the rating and the year. And I was thinking, have these ratings improved as the years have gone by since like 1888 or whenever this analysis started. And so for that, we don't really care about the titles of the films. We don't really care about their IDs. We really just want to look at their rating, their year. So I really want to simplify this data to just pull out these two variables of interest. And to do that, so to pull out these two variables, we're going to use a command called select. Or I guess it's not really a command, it's the right name would be function, or a method called select, which will let us kind of condense this data so we're only looking at two variables, the year and the rating. We would write that, and I'm going to store this new data set into a variable called rating year. Kind of self-explanatory. These are the two variables we're looking at. And we're going to call this by typing select, then the name of the data we already have. And specifically, we want to pull these from this first data set, this raw Bechtel. We don't really care about movies at all. So I'm going to indicate that with these little double brackets and the name of the data set, raw Bechtel, and then just listing out the variables that I want to select, that I want to pull out of that data set. So here is that command. I'm going to run it. And now we have this new data set, rating year, with just the year and the rating kind of going down. So that looks like exactly what we want. And now let's look at that data again. So let's say we want to construct a scatter plot, which, spoiler alert, is what we're going to be doing. It's kind of weird if we have like a whole bunch of movies released in 1906, because each of these points represents a different movie. We don't really need, I don't know how many there are, 7 points for 1906. We just kind of want one. Otherwise, this scatter plot is going to get extremely crowded. There's going to be a lot of vertical columns, especially like, 20, and when we get to like the 2010s, where there's like, I don't know, 100 movies released a year that we're going to look at here. So we're going to want to kind of condense that into one point that represents the average score. Obviously, there's different ways of doing this, but for the sake of this visualization, I'm just going to look at the mean for each year. And so we're going to construct another data set called mean rating year, which just compares the mean. I'm going to construct this new data set called mean rating year, which just compares the mean rating for each year to the year. So instead of having those 7 data points per year, we're just going to have 1. But before we can construct that, we need to kind of group this data set by year. Sort of, instead of having a whole bunch of points, one for each year, we kind of want to tell R that, hey, I want all these 1904 points to kind of go together. And the way we're going to do that is by running another useful function called group by, which is pretty self-explanatory. This will just let us group by a particular variable. And so we're going to group by year, which I'm indicating here. And this just indicates that I want to look at this data set and I want to save that data set again, but this time grouping by year. So let me run this. There we go. And now that we've grouped our data by year, we can build this new data set that compares the mean rating to the year. And we do that by using a function called summarize. And again, we're going to input the name of the data set. And we're going to use and we're actually going to make a new variable. Instead of the rating variable that we had before, we're going to make mean rating. I'm going to set that equal to the mean of rating. And our ratings have already been grouped to a year. So it'll automatically sort of calculate the mean for each year when we do this. So we're going to take the mean rating, and I'm going to type this out, na.rm equals true. And what this little command, and what this thing does is remove any missing variables. So say we had some movies that weren't rated and we just had like an empty slot there. So we wouldn't want to include those in the mean because we would probably get an error. So this just removes them for us. I'm pretty sure in that data set we actually don't have any missing data points, but it's a good practice to use to make sure you're not getting any errors from this. So I'm going to run this now. And again, this will make our new data. And here we can see that it's nice and neat. Now, each year has its own average rating. So instead of having like 7 points that are all 1906, we're just going to have 1. And this is going to make our visualization look a lot nicer, a lot neater, at least. Yeah. Okay, now comes the fun part, because until now, we've mostly just been typing in a lot of letters and numbers without seeing anything exciting pop up on screen. So now we're going to get some of the actual visualization going on. And one last boring command before that is to run this this package called ggplot2. Now this package is extremely popular with people who do data visualization, especially if they're trying to build like a scatter plot, which is what we're going to be doing. So I'm just going to run this. Whoops. I'm just going to run this. And there we go. Now we can use code that comes from this package. And the very base thing we can do with this is make a plot, a ggplot. And all we really need for that is the data set. And we're using mean, rating, year, the one we've just constructed, the one that we want to visualize. Let me run this code. Okay, obviously that was kind of underwhelming. There's nothing here. And that's because we haven't specified what we want it to do. We haven't specified the axes. We haven't specified whether we want points or a line. So we've gotten started here. This is like a valid command, but nothing's really happened. So now the next step would be to add, would be to map our variables onto the axes. And this is easy. We just have two variables. So we're just going to specify which one goes where. So as is usually, we're going to put time on the x-axis. So we're going to say x equals year, y equals, we call that variable up here, we called it mean, rating. And this is the way this is formatted. So we specify the data and we map variables onto the axes. So let's run that. Okay, now it's starting to look a bit more on a graph. It's an empty graph. But we have our axes. We even have labels on our axes, which aren't very neat, but they're there. So we're making progress. And now our next step would be, and at this point, I'm just going to say this data equals mapping equals isn't really necessary. R just kind of knows automatically what you're talking about, where these first two parameters are going to be your data and your mapping. I just put them here for clarity, but really all you need is the name of the data set, comma, this thing you're mapping. All right. And we're going to add some points. We're going to do that using something called a geom command. And a geom function, anything that starts with geom underscore, is going to add geometric objects to your graph. So as you can probably guess, geom underscore point is going to add point objects, but you can do we're going to see even more where you can add lines, curves, triangles. I think there's lots of different objects you can add, but all of them start with geom, geometric, underscore. So if we run this, it's gonna plot our points for us that are in our data set. So we can kind of see things are coming together. We've made a scatter plot. Now we just want to make it clear for the viewer to understand, because that's the whole point of data visualization. Like we can read this pretty well if we look at it for a long time, kind of, oh, it's going up and steadying out, kind of going up here again. But if you're looking at it from like a few feet away, just glance at it, you probably won't get too much information out of this. So let's work on really making it a great visualization of this data. So at this point, as I'm looking at this scatter plot, I'm a little concerned by these bunch of points at 0 here. And this is data from like the early 1900s, late 1800s going on here. And if you, hold on. But let's go back here and look at the original data. And we can see that pretty much only one movie, this is like a long time ago. So we have like one probably like silent movie coming out every few years. You know, the type where they had to like crank it out, someone had to manually play the movie. I don't know, but there were not a lot of movies coming out. And so that one movie, which obviously did not even come close to passing the Ductal test, is the only one that's representing this whole year. And that makes me feel like maybe we should just get rid of these points, because these aren't really a representation of what was going on in this year, because there wasn't much going on in this year in the first place. There's just one movie coming out. And to me, it looks like this kind of messes up our whole trend that we have going on, you know, just these points lying at 0. And I don't know if this is a sound statistical practice, just deleting these points. It's probably not. But for the sake of our visualization, that's what I'm going to do. I'm just going to go back here, and I'm going to delete these points at 0 from this data set. So they're just not plotted on our scatter plot. And the way I'm going to do that is with this command. I'm going to save it to the same variable, and I'm going to use a method called filter. And filter lets us easily sort of take out outliers or data points we don't want by, you know, adding a filter. So in this case, we're going to use this existing data set, and we're going to filter in a way where we're only going to keep points that have a mean rating greater than 0. And this will easily let us just get rid of these. I'm calling them outliers because I don't think they're representative of the whole year. I'm just going to get rid of these. Okay, so it hasn't shown up on our graph, obviously, because we need to re-graph this data. And now I'm going to actually save this graph to a variable. I'm going to save it to the variable graph. So we don't have to keep typing out this every time. Because if you've ever worked in R, you know, there's a lot of like plus signs. You keep sort of adding on to our base thing. We had this, and then we kind of need to write all of that out again and add some more, here, add some more. And now instead of doing all of that, we can save this graph in a variable and then just write graph plus whatever we want to add. And you'll see what I mean in a bit, but basically that's just going to save a lot of typing time and a lot of space. So we're gonna, you know what, I'm just gonna copy. We're gonna do this exact same thing, except now our mean rating has changed, where we've removed anything that's, any mean rating that's equal to 0. Now the main focus is gonna be on making this graph as easy as possible to understand. And the first step is just to make it look nicer. Make these points are kind of ugly, in my opinion, you know, the little black dots. We're going to make them look a bit nicer, and hopefully that will also improve the visualization. So again, the reason we made this graph is now we don't have to type all this out. I'm just going to now, actually, I'm gonna have to redo this because I already added .geom point here, so I can't just, I need to modify the parameters inside of this. So I'm not gonna be able to take advantage of this stored variable just yet. But you'll see what I was talking about in a bit. So now I'm gonna modify the parameters here. When we can actually add 3 different things that will change these points, these geometric objects. We can change the color. There we go. We can change the size. And we can change the transparency. And I believe the command for that is alpha, but let me check. Yep, this alpha will determine transparency. So for color, hopefully you're already familiar with the color library in R because it's one of the most insane things I've seen. Oops, wrong command. Color, right? There we go. There's so many colors. I picked one ahead of time because I'm not going to sit here and go through all of them, but I encourage you to experiment. You can make some really pretty graphs out of these. But I'm going to make my points turquoise 3, because there's apparently many shades of turquoise, 5 to be exact. The next thing I'm going to play around with is size. I'm going to make these points kind of bigger. So I'm going to set the size to 2. I think it can be anything up to like 10, maybe even bigger, but to a point, you know, we have these big dots. It's not going to be great for visualization. So I'm just going to make these at 2, not too huge. And for the sake of demonstration, I'm going to change the transparency. This is a value anywhere from 0 to 1. Right now it's at 1 because they're not transparent at all, but I'll set it to 0.7. Let me run that. Oh. Okay, wait. Let me get rid of this. Okay, sorry, I just tried to run this, this code, but I set these not as numbers and I got an error. So that's why everything suddenly went blank. Make sure you only put things in parentheses, in quotation marks that should be in quotation marks. This should work now though. There we go. And now already to me, that looks kind of nicer. Maybe I should have picked a bit darker shade, but this will work just fine. And now the only thing I'm gonna do, I don't really like it when they're semi-transparent, so I'm gonna get rid of this alpha completely and set it back to the default opaque thing. There we go. So now we have our points looking a little nicer. Next thing I'm gonna do is add a regression line to this data. And we're gonna do this with another geom function. This time it's called geom_smooth. And the way I'm going to do this, I'm going to save this graph we just made to this graph variable. All right, so once we've saved this graph into our variable, we can add a line of best fit, this smooth function. And before we run that, we should add a parameter for the type of line we want. And we have options. Right now I'm gonna, this obviously this doesn't really look, it could kind of be a linear graph, but to me it looks a little wonky. It doesn't really look linear, but we're gonna set it to a linear model anyway by typing method equals LM, and this LM stands for linear model. So let's run that. And R sort of generates this nice line for us. Presumably this is a least squared regression line. maybe not though. It's a linear model anyway. And it also, this little shaded region is our confidence interval. So it's nice, it gives a little confidence interval for the line. And yeah, but as I was saying, this does not look like a very good line. If we were doing significance tests, you would look at this and you would not want to use a linear model. So let's not do that. Let's try something else. We can also try a let's see, a LOESS, which means local regression fitting. So let's run that. And what this is going to do is it's going to make a line that looks like it fits really nice, nicer than the linear model anyway. And that's because it reevaluates the regression fit at a local points. I'm not an expert on this, but I think what that means is like, you know, it takes this little segment. It's like, oh, here, like this parabolic shape would work nice, you know, and here this like this other curve would look nice, and it sort of reevaluates it at local points, which is why it looks like it fits a lot better. But the one I'm going to go with is I'm going to, and we're going to go with the method equals linear model again, except this time linear model. So usually when you run linear model, it has this sort of unspoken default formula that it's going to use where it says y tilde x. So if I, whoops, tilde x, where if I run that, it's going to come up with the same result we had earlier, where it's just a straight line, because, you know, thinking back to a math class, y has the same sort of order as x. This equation is order to 1, so it's going to be just a straight line. But here we're going to have a linear model where the line isn't quite as straight. We're going to write formula equals, and let's try this to me, you know, we could have a polynomial of degree 2, but that's just like a little parabola, not very exciting. But degree 3, things start to get kind of curvy like this, you know. So I'm going to try that out. Y tilde, and the command for that is poly x comma 3, and this will sort of fit it to a an equation where x is raised to the 3rd power. So hopefully that'll look a little better. Yeah. So this is still like a linear model technically. It's not just like reevaluated at local points, but it's not a straight line. It's a nice curved line of degree 3 that fits this data a little better. So I'm going to stick with this. Obviously, it's not perfect, but I think it's a pretty nice representation. But now what I'm going to do is I'm going to add some parameters to this. I'm going to set SE equal to false, and that's going to remove this little confidence interval, because in this case, we don't really need it. It doesn't look that great. It's kind of unnecessary, I think. So we're going to remove that, and we're going to set our color equal to black, because our points are already blue, so this blue line doesn't look that great. Now let's run that. All right, so that looks pretty nice to me. And we're going to save this to our graph variable. All right. So now that we've improved the look of this graph, we can really get a sense for what's going on, you know. Now that I'm looking at it, yeah, this regression line probably isn't perfect, but it'll do for our purposes. So yeah, let's take a look at this before we put the finishing touches on it. So it looks like as the year increases, in general, the rating increases, which is a good sign. You know, we're getting some more representation of women in our movies. But yeah, we can see that things went up pretty steeply from 1900, even before 1900. We have a point here, to 1930, 40-ish. You know, we went from having like, there were points around 0 here before. Obviously we removed them, which is probably a good thing for when we constructed this regression line. Otherwise things might have been really messed up. But, you know, so yeah, we have things going up steeply here, and then sort of stagnating. It looks like things aren't going up. Obviously this graph has a very narrow range, you know, and that's something to look to pay attention to, because the lowest we can go is 0, the highest we can go is 3, and for individual individual data points, before we sorted this graph, before we took the means, data points, the ratings could only really have 4 values. They could be a 0, 1, 2, or 3. So it's not like we're taking a mean of a huge range of numbers here, and that's something to pay attention to when we're looking at this. But yeah, it looks like things are sticking kind of around 2 here. You know, you have those 2 female main characters who talk, right? You're having some women in your movies, but they're not talking about things other than men. So that's kind of what this indicates if we think back to like what the Ductal Test actually means. But you know, as we're going into the 2000s, things are looking like they're starting to rise again, especially the last few years. The mean is almost at 3, which is great. So hopefully things will keep going up until, you know, things are closer to the 3 range. But yeah, now now that we've sort of organized this data, plotted it, it looks nice, we can really get stuff out of it. So now this video is almost gonna come to an end. I know I've been rambling for a bit. At this point, I'm just going to add some labels to the axes to really make this look more professional, make this something that someone who doesn't have an idea of what this data is, they could look at this graph and really understand what is going on. So with that, we're gonna, again, we save this to a graph variable, so we can just hit that plus and add this command labs is gonna add our labels for us. So we're gonna set x equal to, and this is gonna set the x-axis to year. Make a capital Y, looks better. Set of y-axis equal to, say, Ductal mean Ductal test rating. And then set our title equal to, you know, mean Ductal test rating per year since, let's say, 1899. This isn't a great title. This doesn't really accurately represent what's going on here because we've deleted some points. Per year is a little vague, but on the spot, that's the title I came up with. So we're sticking with that. Let's run that. And there you go. We have some nice labels going on here. We have a nice title. Yeah. And obviously there's more stuff we could do. We could get rid of this weird gray stuff in the background. We could center our titles or axes, make our labels a little bigger. And I'm gonna do some of that stuff in later videos. But the point of this video was really to just walk through the process. You know, I took you through, we found the data, sort of got an idea of what this data actually is, then took this data apart into what we really wanted for our visualization. And then we went through and made this data concise and clear, and I think it looks pretty nice. And again, we might look at this data again. We might look at other Tiny Tuesday data. Tidy Tuesday. All right, thank you for tuning into this video, and I'll see you in the next one.